Hey everyone, and welcome to the fourth part of the Go Graph tutorial. First, I apologize for any inconvenience I may have caused any of you from last week, since the episode got long, and I decided that it would be better if I just stop and just continue, this week. And for that reason, uh, I want to have I want to have one video released today, which is Saturday, and another one tomorrow with the finished version. So today's video is gonna be a tutorial, but tomorrow is not so much going to be one. It's more or of like, here's a finished version, and I'll put it down in the description for that day's video. So now that's announced. As promised, I will first. I want to get an ear and get you started on this goatee. So you have a place to start for it, and hopefully finish on your own. So with this ear, I'm talking to you. I'm thinking about which equation fits, and I got two equations in mind. And as always, there's usually more than one correct equations. So first one I came to my head is a hyperbola, and that graph looks, and equation for this one is going to be an upside down hyperbola. We negative for upside down, and a 1 plus x squared. Let's fit this at around 2, a little bit past 2. It places at 4, 3.5, 7. Close enough. And then there's another one to have in mind, which is a cosine graph. Cosine x minus 1, 2.125. So that's plus 3.375. So we plus 2.3 still. 375. But they both fit really closely, and in the interest of variety, I would go with a cosine graph, even though I feel like the hyperbola might be a better choice. You know what? Cosine works. They will both work out like almost the same. Like, and if you look at how all these two lines fits, like you can't quite see the difference. Like the difference is so tiny until you hit like 3.5. That's what it looks like. Uh, so I'm gonna go with a cosine, uh, because why not? So let's see. This is like squeezed by like a tiny bit, like just it's like a hair more than 1. I think like 1.05. I'm thinking at that scale. And this one should be brought down by a little bit. 1.25 seems to work out the best, and we'll just make it x is greater than or equal to 1.881. And that's for this line down here. This line down here, it would probably make the most sense to use a hyperbola, but they're making like similar graphs with similar shapes be well, cosine doesn't have a similar shape. It's more like it would work out similarly if you take like a segment of it. So if you take a segment of it, it will look like you can usually fit it with a parabola. So we can do 1 minus, I believe, last I checked, was just now. X plus, see, let's go x minus 2 1/4 squared. Actually, plus, I had that wrong. And maybe move it over by 5/8, and maybe this looks like it needs to be widened a little more. So we can divide that. I'm gonna just go 1.5 squared. I feel like that might fit. I should put Powerball. I got lucky with this one, and I'm gonna subtract like 0.01. That barely made a difference. 0.05 seems to work. Try 0.1. I'll go with 0.1. 0.05 works too. So we'll go from 2.292 and that's going to touch this at 3.325. That's here. And over here, we're going to need the y values again. So this has a y value of 1.437. $1.419. 1.419, so it's going to go to, this is the top half, and I want the bottom half. I need to put this into 2. And this one, I have to pick it off from this y value. It's about 2.222. All right, and this is we have the skull of the goat done, and then we can, and we've also finished doing one side of the ear. Right, and to help you get started on the goatee, it can help you choose some equations. This one looks like an equation that would be facing sideways. You can choose a sideways facing parabola or similarly related equations, or you can choose a sideways. No, not even sideways facing. Yeah, you can choose sideways facing circle. It's um not needed, but it can fit too. So the one that I'm going to go for is I'm going to get cut off. So I want to tell you more about it when I return. All right, so one I'm going to go for the sake of variety, I'm going to go for x is equal to y squared. And this is the equivalent of taking an inverse of an equation. So the inverse of an x squared equation is square root. You can get that by solving for y, and you'll get the square root of x. Alright, so over here, we're going to shift x to the right by 1. Let's try 1 unit. I'm going to move y down by 2 units. This is not how my intuition works, because normally I subtract from y to go down, and I subtract for an f from x to move to the right. So this is going against my way of thinking here. That could be a problem. I'm going to make adjustments for it to fit, and this seems to work out. You can have adjustments that you want. Maybe go 1 point. Set by a little. Does this stretch it out? It's getting thinner. It should go the other way. 0.75 or 875. 75. And then the next equation, we can even go as far as just drawing a straight line, but this is where there's like a slight curve to it, and I'm choosing from 2 different functions. They're both really similar to each other. E to the minus x, and use a different color, and 2 to the minus x. E to the x has a faster slope, so we can I might end up adjusting it to going as far as like 3, 4 to the x. I like E. My personal preference. I'm going to subtract 1 from that. Start working my way down. We can like speed up the way it's sloping down by tampering with the x values. Maybe move it over by half a unit. This is starting to line up. Okay, maybe stretch this up a little bit. Okay, and this looks like something that we can stick with. All right, which means, oh, with this line, we can now set our boundaries. This is negative 1.242 to 2.149. And then this equation is screaming parabola, or not parabola, hyperbola at me. And since this isn't starting at like a 0 slope, this is starting at, you can see like a bit of line incoming before it starts going negative. So we start with for perhaps the first time, and the general equation of hyperbola, and that's x squared minus y squared to 1. I probably should have started with the general equation of hyperbola before I went into showing you the half versions. Alright, and then we should shift the x by over by however many units find fit. Then we can move this down. Let's go like that. And then we stretch it. Stretch it up. We're gonna go and divide. Shift it over by a tad bit more. 0.625 worked out. I like 625. Which means this one's going to go from the bottom of this graph, which is negative 2.149. What is going on? Oh, I keep on turning off. I keep on still hitting that. What is this not understanding? Try adding an equal sign to turn this into an equation. It is confused, some odd reason, and there's a negative 1.737. And this one is go with less than negative 1.737. All right, so I hope this gets you started on helping you finish the graph. This is bothering me, so you can do that by setting an extra constraint. X is greater than what this number is, negative 0.625. All right. Well, there you have it. Yeah, as I said, I hope this helps you get a nice idea on how to continue finishing this entire graph. Some other ideas that might help you out is this graph is symmetric on the x-axis. So one of the things that you would need to do to finish the other half is to multiply the x, what's impacting the x by -1. In other words, you're transforming, going from f of x to f of negative x. So if you want to know more about what that means, stay tuned for tomorrow.